Hi, my name is Dan Foley, and I'm going to be teaching you how to calculate the volume of a cylinder. Alright, first off, the formula for calculating the area of a cylinder is this. Let me start with the wrong pen. Alright, yeah, so first off, the class is calculating the volume of a cylinder. Of a cylinder. Okay. First though, like I said, we're going to go with the area of a cylinder. Okay, and that is pi times the diameter times the depth. And that equals area in square feet. Okay? Area in square feet. Alright? Keep in mind all these units have to be in feet, or otherwise you're going to get a bad answer. Okay, so that's it. The area of a cylinder is pi times diameter times depth. Now remember, if they give you the radius, you have to multiply it by 2, and that will give you the diameter. Again, this all has to be in feet. Everything has to be in feet. Okay? So anyway, that is the area of a cylinder. Okay, now what I'm going to do is I'm going to erase this. We're going to take it one step further. Okay, now we know the areas, how to do an area. Now what I'm going to do is show you how to do the volume in cubic feet. Okay, so we're going to do that. So the volume of a cylinder in cubic feet, volume of a cylinder in cubic feet equals pi again times the diameter, okay, times the depth. Okay. So the volume of a cylinder is equal to the area of the base times the height. So that's the difference here. We're going to include the height. Alright. So the volume of a cylinder is equal to the area of the base times the height. Okay, that gives you the volume in cubic feet. Okay, there you go. Keep in mind, everything you're using has to be in feet. If they're not all in feet, you'll get an answer wrong. Unless you want to do an area of a cylinder in cubic inches, then everything would have to be in inches, and then your answer would be in inches, cubic inches. I'm sorry. All right, so that's the equation. You can roll that back, look at it, look at my text, send me comments, concerns, errors, you name it. Anyway, so let me break this down. Okay, so we're going to just do a little bit of volume. Again, volume in cubic feet equals pi r squared times h height. Okay, again, all these are in feet. Now, the number pi expressed in decimal form is this, 0.785. Okay, So now we're going to do a little bit of shenanigans here. We're going to say 0.785 times diameter squared, okay, times the height. Okay, so this, keep in mind, okay, now we're changing it up a little bit. We're going to go diameter squared to the height. All these have to be in feet. All right, so our imaginary tank has a diameter of 100 feet, okay? So here's our tank. It's short, it's fat, okay? So he's 100 feet wide, or I'm sorry, he has a diameter of 100 feet, and he is 12 feet tall, okay? Okay. So now I'm going to point 0.785, which is pi expressed as a decimal, times 100. This guy here, the diameter, times 100, times the diameter again, times 12. Okay. And when I multiply all that together, I'm going to get equals 94,200 cubic feet. Okay. So now, okay, we have the volume in cubic feet, 94,200. You know, again, it's a 100-foot diameter tank, 12 feet deep. All right, now, if I want to convert this to gallons, okay, times 7.48. Where I got the 7.48 is the amount of gallons occupying 1 foot of space. So if I had a box, let's say if I had a 1 foot by 1 foot box, 1 cubic foot would have 7.48 gallons in it. So hopefully that makes sense. 1 cubic foot equals 7.48 gallons. Okay, when I multiply these two numbers together, I get this number here, 714,616 gallons. Okay? So what we're saying here is a tank with a 100-foot diameter, 12 feet deep, would contain 714,616 gallons. Now keep in mind, when you do this calculation, that is from top to bottom. Okay, if the tank is half full, then it's going to be, divide this by 2. If it's so basically what we're doing is we're calculating the volume of the tank totally full. And keep in mind, in real life, tanks are seldom always full. There's usually some kind of freeboard or something like that happening. So anyway, that is how to calculate the volume of cylinder. Some of the cylinders you'll find in a water treatment plant are digesters, DAFs, secondary clarifiers, primary clarifiers, gravity thickeners are all examples of cylindrical structures in a wastewater treatment plant or a water plant. Anyway, I hope that helps out. Again, this is rough stuff. This is the first cut, first take. We're probably just going to post this on YouTube and then edit it later. My goal this week is to get 3 videos up on the web, and that's what I'm going to do. We'll come back later, edit, correct, and all that. My name is Dan Foley. Email me at dfoley@dtmfoley.com with any suggestions or comments or concerns or what have you. Oh, especially if you have anything that you'd like to see explained, I'll get to it and see if we can come up with a good answer. Anyway, I hope you enjoyed this. Again, real fast, quick, dirty, posted to the web today. Catch you later. Hope you enjoyed it. Goodbye. The end.